Welcome, my dear students. We are going to study effect of particle size and efficiency of nanoparticles as catalyst. The size of nanoparticles is in the nanometer range 1 to 100 nanometer, where 1 nanometer is equal to 10 to the minus 9 meter when compared with the size of atoms. The atom size is 0.2 to 0.4 nanometer. Nanoparticles are much larger. Nanomaterials can be metals, ceramics, polymers and composites. Nanomaterials are chemical substances or the materials that are used at a very small scale. Nanoscale size range from approximately 1 to 100 nanometer. Nanomaterials used as a catalyst for variety of homogeneous and heterogeneous catalysis. Methods for the preparation of nanomaterials. Nanoparticles of uniform size can be prepared by two main methods, physical method and second, that is a chemical method. In a physical methods, the bulk material is reduced to nano size particles by using a mechanical force or by vaporization. And in a chemical methods, metal ions are reduced to metal atoms which aggregate to form nano size particles. Chemical methods are usually preferred as they yield large quantities of homogeneous nanoparticles. For example, transition metals, mostly palladium, iron, gold, nickel, platinum nanoparticles. Transition metals nanoparticles in colloidal solutions are used as catalyst. Metallic nanomaterials are commonly made up of transition metals. Nanostructural materials occur in different geometrical configurations like tubes, rods and wires. Properties of nanoparticles. Nano-sized particles exhibits a quite different physical, chemical and mechanical properties as compared to the bulk material. Changes are observed in color, hardness, density, melting point, mechanical strength, elasticity, ductility, electrical conductivity, thermal conductivity, etc. For example, the hardness of nickel in a nano form is 5 times that of its bulk form, but the electrical conductivity is 3 times less. Gold in the bulk form is a golden yellow in a color with a metallic luster but shows different colors in the nano form. Purple color in a 50 nanometer size, bright ruby red color in a 25 nanometer size and orange color in a 1 nanometer size. These changes in properties are characterized to the reduction of size during the preparation of the nanomaterials. The resulting in a considerable increase in the surface area to volume ratio. Nanoparticles have a very high surface area to volume ratio and make excellent catalyst. The surface area to volume ratio is inversely proportional to the particle size. The larger surface area makes nanomaterials excellent catalyst for chemical reactions. The relative surface area is greater than the bulk material. When the size of the nanoparticles decreases, the ratio of the surface to bulk atom increases. As the particle size decreases, the bulk density increases. Nanomaterials are more reactive because nanomaterials having high surface area. Nanomaterials are materials created using the nanoparticles. We here see that there is a hardness of the nickel in a nano form is 5 times that of its bulk form, but the electrical conductivity is 3 times less. Means nanoparticles of the nickel has the hardness is more and electric conductivity less. If you consider gold, the color that can be changed from bulk is a golden yellow in a color with a metallic luster, but it shows different colors in the nano form. Purple color, bright ruby red color and orange color. Purple color 50 nanometer size, bright red color red 25 nanometer size particles, nanoparticles, and orange 1 nanometer size, that is nanoparticles. The nanocatalysis. A nanocatalyst composed of nanoparticles. Catalyst in the nano size 1 to 100 nanometer are used to catalyze a variety of chemical reactions. Catalytic activity largely depends on the active surface area of the catalyst. Hence, nanomaterials have been found to be effective catalyst for several industrially useful reaction for which the catalyst is used. Nanocatalysts are heterogeneous catalysis involving an active surface on which chemical reactions can take place. Nanocatalysts are of two types. Catalyst composed of metal nanoparticles supported on metal oxide, for example gold as a catalyst. It is supported on the metal oxide like nickel oxide, iron oxide, cobalt oxide, tungsten oxide. Means gold on NiO, gold on Fe2O3, gold on CO3O4, gold on W3O4. High surface area nanocrystalline metal oxide. Other type, that is a high surface area nanocrystalline metal oxide. Some examples of natocatalyzed reactions are as follows. Gold supported on metal oxide like nickel oxide is used to catalyze the oxidation of carbon monoxide and hydrogenation of unsaturated hydrocarbon. Titanium oxide, titania based nanocatalysts are used in photocatalysis, which is applicable in the utilization of solar energy. Titanium oxide based nanocatalysts are also used in the treatment of pollutant and waste waters, as titania is an effective oxidant for the oxidation of organic carbonaceous matter found in the waste waters to CO2 in the presence of oxygen and water. Cobalt nanoparticles are used to catalyze the oxidation of cyclohexane to adipic acid. This reaction is used for the industrial preparation of nylon 6 polymers. Oxidation of reaction cyclohexane to synthesize the adipic acid. The cobalt catalyst is used, the temperature maintained for 100 degrees centigrade, and reaction is occur at or maintain reaction for 15 hours. A cyclohexane is converted into cyclohexanone, then alcohol, then the adipic acid. Nanocatalysts used in automobile catalytic converters to remove toxic and noxious gases like carbon monoxide and nitrogen oxide, carbon monoxide and the nitrogen oxide. They are also used in power generator to prevent environmental pollution due to the burning of coal and petrol. The carbon monoxide is a cold poisonous gas. Carbon black in a nanoform is used in car tires to increase the life of the tire and to impart a black color. Metallic nanoparticles can catalyze a carbon-carbon coupling reaction such as hydroformylation of polyamines, the synthesis of vitamin E, and the Heck coupling and Suzuki coupling reaction. In a Heck coupling reaction, the palladium nanoparticles are used. In a fuel cells, nanoporous materials, platinum, are widely used to make cathodes. The complete ethylene oxidation in the temperature range of 25 to 220 degrees centigrade, carbon black is used as support for platinum of the carbon. Then ethylene oxidation on platinum carbon, it is a support for the platinum catalyst. Ethylene reaction with molecular oxygen, it gives ethylene oxide, and the ethylene reaction with atomic oxygen, it gives carbon dioxide and the water. The hydrosilation of styrene, the palladium or Au, that is gold, nanoparticles used. Nanocatalyst applications in water purification, fuel cell, energy storage in a composite solid, rocket propellants, biodiesel production, in medicine, in a dye, etc. Thank you.